Question 3 is a good example of having to read things carefully. We are naturally mathematical people, and being naturally mathematical, you look for patterns, and by looking for patterns, sometimes you trick yourself. The graph of, if you start reading this and saw this equation, 99% of people will assume that this equation matches up with that graph because 99% of math equations do that. When they give you an equation and a graph, they match up. But in this one, we have to be careful because it says the graph of y equals 1 over negative 2x squared minus 0.5 was reflected in the x-axis and its image is shown. So the red graph is the image, not the original. If I put a blue box around the original, if the image was after a reflection in the x-axis, can you see that your original would have had to have been like this? That's the original graph. I just wanted to point this out because math is something where you have to read carefully. Often in a question that you're getting wrong, it's because, well, let's read it over again. Are you doing what the question is asking? Oh, I made an assumption to do something else. And every single person in this room will do many things in their life because they make an assumption for what is not there. Okay. What is the equation of the red graph is what we're trying to find. So again, when you see this reflected in the x-axis, you should think about all of the things, including the algebra, that this is a vertical reflection, meaning that the negative would be outside of the function. The function we have, that was our blue equation. We need to write an equation for the red one, and to do that, all we need to do is rewrite our blue equation, which was this, and put a negative in front. Because that's all a vertical reflection is doing, is taking the original equation and putting a negative in front. And that's what this notation in purple means. The blue is my f of x, that's my original equation. I just need a negative in front. And that will cause us to have a vertical reflection. Now, this is a perfectly right answer, the red one. But what I'm going to do next is I am going to say, let's say you had this question as multiple choice. And on a multiple choice, I'm going to give you 3 options. And then it's one of those multiple choice questions where it says, all 3 are right, only A and B, only B and C. You hate those ones. I hate those ones too, right? It's like, oh, I like it when there's just one right answer. It's not like, because you're like, I'm sure about B. And maybe C? Oh. Anyways, it's going to be one of those. So, and we're going to start off here, the black one. I'm going to say, I'm going to take that negative, and let's say it showed up like this. And then I'm going to do one in green, part B. Take that negative and this. And then in blue, part C. Take that. There we go. So if you were asked to simplify and get rid of that negative outside of the brackets, which would you do? Would you do black? Would you do green? Would you do blue? Okay? Don't say it out loud. Keep it in your head. Would all three of these be right? Would all three be wrong? Is there only one right answer? Is there multiple right answers? So you have to simplify that negative outside of the brackets in the red, because it's multiple choice, and these are options. Which would you choose? And the reason I do this is because there is a very typical math mistake that happens here. And if you make it, you want to know that you're making it to see it so you don't make it again. So I want you to decide which one you would do. And I'm not going to get you to say it out loud, because I don't want to be like, ha, you picked the wrong one. That's not the purpose. But if you do pick the wrong one, you want to know what you're doing wrong and why you're doing it wrong. Okay? So, I will explain, and everybody's got their decision? Okay? The black one is correct. The green one is wrong. The blue one is also correct. So why are they correct and why are they wrong? Well, a negative outside of the brackets is like a negative 1 outside of the brackets. And a negative 1 outside of the brackets could be written as negative 1 over 1. Because I'm multiplying by a fraction, I need to use my fraction rules. How do you multiply fractions? You multiply the tops, you multiply the bottoms. Can you see if I put a negative 1 in the top, that would multiply to get the black one with a negative 1 on top? And if I multiply the bottom by a 1, the bottom would stay the same. And so that is why the black one is correct. Now the reason the green one is wrong and why some of you chose the green one is because you're mixing up fraction rules with distribution rules. There is a rule about distribution where you have to distribute, right? But if I multiply the top by the negative and the bottom by a negative, that would be multiplying by negative 1 over negative 1, which is positive 1, which is not the same. So if you change all of the negatives, because your mind is thinking like distribution, this is not the same with a fraction. We do have distribution in blue. If in the blue one, that's like thinking of the negative 1 as 1 over negative 1. And here, because I'm multiplying the bottom and I have more than one thing on the bottom, I would have to distribute when I multiply. So that makes it positive 2x squared plus 0.5. And again, the mistake is because your brain is mathematical and you're looking for patterns, but you used a rule from distribution in a fraction. And you have to be like, okay, I applied it in the wrong spot. That can happen. It's going to happen lots. Math is very good at creating all sorts of problems in your brain and making you have to sort them out. Questions to do for this one are 7, 8, 9, and 12. And we are actually going to do 12 together right now. So I'm going to get you to circle those 4. And then turn to example 12. And the reason we're going to do example 12 is because example 12 is a problem-solving question. And you will get some problem-solving questions on your test. And what makes something a problem-solving question is usually something like this. Determine where the graph of f of x equals x squared plus x minus 6 intersects the graph of each function below. How do you know? You read the question, and your first reaction is, I have no clue. That probably means you're in a problem-solving question. Problem-solving questions in math result from the fact that after you learn something basic, you now can answer a whole bunch of questions, way too many questions that we have time to answer in class. But even though you've never done one like this before, you do have the tools to solve it. And you have to use some problem-solving strategies to access those tools. So generally, on a question where when you initially read it and you have no clue how to solve it, because we've never done one like this before, you have to access your problem-solving skills. Number one problem-solving skill is, well, what do I know? So in this question, it's like, determine where the graph of f of x, oh, that's a parabola. I know it's a parabola that opens up. I probably could go back to my grade 11 and graph it really, really accurately, but that would take me some time. And right now in the problem solving, I'm just looking at big picture, what do I know? Maybe something comes out of here that helps me, okay? Then in part A, we have y equals negative f of x. I know from that, outside is a vertical reflection that reflects something over the x-axis. So I might have an x-axis somewhere. I'm going to draw an x-axis. I'm going to imagine if my x-axis was there, and I flipped the blue graph over the x-axis, it would be like this. That's a possibility. I'm just imagining things now because I'm problem solving. If it did this, does it ever intersect? No. But I imagine maybe my x-axis, was here. If my x-axis was there and I reflected it over, then there would be 2 points where it intersects. What would those points be? Those points would be an x-intercept. So at this point in my head, I say to myself, if they intersect, they would intersect at the x-intercepts. So now my problem solving has started off with I have no clue. I wrote down what I did know, and I've discovered that if they do intersect, it would have to be x-intercepts. And then I ask myself the question, well, can I find x-intercepts? Do I know how to do that? Have I learned that before? Yes. Do I need the green equation to find them? Or if I find them on the blue graph, it would be enough. Yes, because they're going to have the same x-intercept. So I'm going to take out my blue graph, my blue equation, and I'm going to say, all right, how do you find x-intercepts? You plug in 0 for y. Have I done this before? Yes. I did this in grade 11. How would I solve a quadratic equation that's equal to 0? Either quadratic formula or factoring. This one factors nicely. X and x, 3 and 2. The 3 is positive, the 2 is negative. So then I could solve this. X is equal to negative 3 and x is equal to 2. And I can write a final statement. Here's the points. They intersect at negative 3, 0 and 2, 0. Now, if I put this question on a quiz or a test, some would argue now it's no longer a problem-solving question. Since we've done one and now you know how to do it, it might not fall into the problem-solving section. Sometimes I still might put it in the problem-solving section, because originally it was a problem-solving question. Okay? We don't have enough class time to go over. Oh, great, battery's done. We don't have enough class time to go over every single All right, we'll test if the new mic works. It all of a sudden went silent, and we know it does. Thank you for noticing the battery was dead. We don't have enough class time to go over every single problem-solving question there can be. I give you some problem-solving questions when I circle them in the homework. And if you're working on a problem-solving question in the homework, and you come in and ask questions, sometimes I use that same question on a test as problem solving, but if you've already done it already, you've given yourself an advantage. Okay? I want to give you as many advantages as possible in this class, but you do have to do part of that on your own, and that is doing questions and coming in at lunch when you have questions. Because if you just go, oh, I didn't get number 10, oh well, and leave it, well then it comes to the test, you won't get number 10 when that same question comes up on the test either. Okay? Let's look at part B on this one. Now that you've problem solved for part A, okay, when we get to part B here, y equals f of negative x. We notice this is a horizontal reflection. We think about our original parabola opening up. And a horizontal reflection would be over a y-axis. And if you reflect something over the y-axis, it's going to be the y-intercept. That doesn't change. How do you find a y-intercept? Algebraically, we plug in 0 for x. So I take my blue graph and I say, okay, I could plug in 0 for x. The math is relatively easy. And we find out that they intersect at 0, negative 6. So again, problem-solving questions are usually ones when you look at them, you haven't seen this question before, but unlike IB classes, I won't ask any unfair problem-solving questions. There are some problem-solving questions in the IB course which they are just designed to be. They actually only want 1 in 50 kids to get it right. That doesn't sound like a very nice thing to do, but that's how they design some of their questions. And so you come out of the test going, yeah, I had no clue on that one, and everybody else you talk to has no clue except for that one kid in class. Of course you got it. That can happen. But in grade 12 pre-calculus, there will be some of these questions, but you have the tools to solve it. And in order to use those tools well, we really have to understand what's happening. If you just know how to do questions because you base your learning on, I recognize this and then I do this, 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 and this, you will never get a problem-solving question. Because problem-solving questions are asking you, do you understand what's going on? Can you make connections? And then with those connections, solve the problem. Okay, so we are done